Good evening, everyone. On behalf of CentreC Electrical and Energy Conservation Society, I warmly welcome you all to the webinar on Comprehensive Overview of Electrical Machines. It is my great honor to welcome our special guest, Dr. Mini VP, retired professor, Department of Electrical Engineering, College of Engineering, Trivandrum. With an outstanding career in teaching and research and numerous publications in reputed journals and conferences, Dr. Mini made remarkable contributions to the field of electrical machines. Next, I would like to welcome Engineer Baby Kuriakos, General Secretary, Energy Conservation Society, for delivering the felicitation.
Thank you, madam. Good evening to you all. ഈ അസിസ്റ്റന്റ് ഇലക്ട്രിക്കൽ ഇൻസ്പെക്ടർ എക്സാമിനേഷനോട് ബന്ധപ്പെട്ട ഇലക്ട്രിക്കൽ മെഷീൻസ് എന്നുള്ള ഒരു സെഷന്റെ ഒരു ഓവർവ്യൂ ആണ് നമ്മളിപ്പോൾ ശ്രദ്ധിക്കാൻ പോകുന്നത്. ഐ ഹോപ്പ് ഇറ്റ് വിൽ ബി വെരി യൂസ്ഫുൾ ഫോർ all the aspiring candidates. Even though very few people are there, hopefully many will be benefited from this. So I wish all the best for all the students and the aspirants, those who are participating in this seminar. And also ഈ ഒരു വിഷയം കൈകാര്യം ചെയ്യാനായിട്ട് ഏറ്റിരിക്കുന്ന മിനി മാഡത്തിനും എല്ലാ ആശംസകളും നേരുന്നു. ഹോപ്പ് ഇറ്റ് വിൽ ബി വെരി യൂസ്ഫുൾ സെഷൻ. താങ്ക് യു അഗെയിൻ. On behalf of Energy Conservation Society, we wish all the best. Thank you very much.
Thank you, sir. I now invite Dr. Mini VP to address the session. Let's give her a warm welcome.
Good evening to all. Now we are coming to the webinar on electrical machine. It is very good opportunity for the students who are preparing the PSC examination. Then first of all we can see that what is the electrical machine, what is its functions and other things. It is a device which convert one energy into the other form is called electrical machines. Then continuously electrical machines are, either it is converted into electrical energy from mechanical energy or mechanical energy from electrical energy. It is generator or motor. Then this is the electrical machine. Then first of all we can see that E and I, that means electrical energy is supplied to the electrical machine. It is an electromagnetic device. Then that machine is converted, that electrical energy, to mechanical energy. Then that is called motor. Then vice versa, that means input is applied as mechanical energy, the output obtained as electrical energy, it is called a generator. So these are the conversion from electrical to mechanical is called a motor, and the mechanical to electrical is called a generator. Then this is an electromagnetic devices. Its working principle is a Faraday's law. When the conductor moves in a magnetic field, voltage is induced. That is a working principle of generator. When a current carrying conductor placed in a magnetic field, it is some working principle of motor. Both are working as depends upon the Faraday's law. Then generally we can classify the electrical machines into static machines, that is stationary machines, and rotating machines. Then stationary machines means there is no movable part. Then one machine is only available for this type of, that is called a transformer. Then rotating machines are first of all it is divided into two, depends upon the input energy applied to input supply applied to the machine, that is called DC machines and AC machine. Input energy applied to the machine is DC, in supply is DC, then that is called a DC machine. Then DC machines are depends upon the operation, we already told that, DC generator and DC motor. AC machines are again divided into, depends upon the operation, synchronous machines and asynchronous machine. Asynchronous machine is nothing but induction machine. Synchronous machines synchronous speed, that is rotating magnetic field produce rotating magnetic field produce അതേ സ്പീഡിൽ motor അല്ലെങ്കിൽ generator rotate ചെയ്യുന്നത്, that is called a synchronous machine. Then synchronous machine is again motor and classified into motor and generator. Then depends upon the input supply applied to the motor, it is again classified into single phase, three phase. In all the synchronous induction and synchronous generator, we can classify it into single phase and three phase. So the transformer is a static piece of apparatus. There is no movable part. Then whenever conductor, it is also working as per the Faraday's law. From one circuit to, that is, it transfer electrical energy from one circuit to another without changing the frequency. Voltage and current we can change, power and frequency did not change. Then an ideal transformer means whatever the input energy we applied to the transformer, then complete an output obtained from the output energy obtained from the output, it is called ideal transformer. That means it has no losses and other things. Then and its efficiency is 100%. But the original, that is real transformer, is not like that. It has an loss. Then different parts of that is transformers figures are here. Then different parts are the core, windings, core is this one, windings, and conservator tanker, then bushings, breather, radiators, and transformer oil. These are different parts of the power transformer. Core, it is made up of magnetic materials having high permeability, such as silicon steel sheets of thickness 0.35 mm to 5 mm, depending upon the requirement, are cut into the particular size and shape and are stocked together to form the magnetic core. It is just like a magnetic form, that is laminated core. The core of the transformer mainly two purpose, that is, it provides a support of the winding and a low reluctance path or to the magnetic flux. These are the functions of the core. Then windings, it has two windings named as primary winding, secondary winding. The winding connected to the source of AC supply is called the primary winding, while the winding of the transformer to which load is connected is known as a secondary winding. Then transformer body or tank or dielectric oil. The transformer tank provide a protection of the core and windings of the transformer. Then transformer core and windings are immersed in a tank, that is a power transformer. Both winding and core are immersed in a transformer oil or dielectric oil. Then it will use as an insulating medium for core and winding of the transformer and absorbs a heat generated. That is, we know that when the transformer is working, heat is produced. That due to that heat, oil is heated, and this oil heat is removed with the help of cooling. Then the oil conservator tank, the main tank of the transformer, is connected through a pipe to a small tank. This one is the transformer tank, then this is the main tank. Through a pipe to a small tank called as conservator tank. The main function of the conservator tank is to keep the transformer tank completely filled with the dielectric oil operating condition, to all operating conditions. Conservator tank is designed to act as a reservoir for the transformer oil. When the temperature of the transformer is increased, the oil inside the transformer being expanded, and the conservator tank provides a space for these expansions and of the dielectric oil. Then the breather is of a transformer consists of silica gel, which prevents any atmospheric moisture from entering to the tank of the transformer with the air. When the temperature of the transformer goes down, it will make the dielectric coil to contact, and hence atmospheric air gets inhaled by the transformer. Then these are the one core circuit diagram of core type transformer. Then core is this one. Core is magnet. When the voltage is applied to the primary winding, the flux is produced in the core. The flux is traveled from one point to another, and that flux is linked with the secondary coil. In that condition, the voltage is induced in the secondary coil as per the induction. According to the principle, E voltage induced in the secondary coil N into d phi by dt, then N is the number of turns in the secondary winding, d phi by dt is the rate of change of flux. This already told that. Then in the case of transformer is again divided into different type. Then as per the phase, we can treat it as a single phase or three phase, and core type or shell type as per the cooling system, self-cooled, air-cooled, oil-cooled. Then based on its core, air core transformer and a ferromagnetic core transformer, from depends upon the capacity of the transformer, we can select a different core. Then based on the voltage conversion, that is step up transformer and step down transformer. In step up transformer, the secondary voltage is higher than that of the primary voltage. Then depends upon the usage application, we can divide it into three: power transformer, distribution transformer, and isolation transformer. In the industry, we call it, we use it as a power transformer. Then in power system, that is distribution system, roadside transformer is called a distribution transformer. And efficiency in all day efficiency or other transformer, power transformer efficiency equal to output power divided by input power. But in the case of distribution transformer, output energy divided by input energy. Then isolation transformer is used as a power isolation, that is its ratio is 1:1. In the case of power transformer and distribution transformer, the ratio is less than 1 or greater than 1. It depends upon the step up or step down. Then based on the winding, the transformers are divided into two winding transformer and auto transformer. In auto transformer, only one winding is there. A part of that winding is used as a secondary. Two winding transformer is normal to one primary winding and one secondary winding. Then based on the insulation used, dry type and oil immersed transformer. Oil immersed transformer, mainly power transformers and distribution transformers are oil immersed transformer. Then based on phase, single phase and three phase. Then core design, core type, shell type and buried type. Mainly use the core type and shell type. Then this one is core type, that is two limb and windings are surrounded by two limbs of the core. It is called a core type. Then middle limbil and winding that is called a shell type. Then buried type is this one. Core is this one, winding is this one, cylindrical shape. Then low voltage winding and high voltage winding. Low voltage winding inside winding, outside high voltage winding. Then next we go to the vector diagram of transformer. We know that transformer has two winding, primary winding and secondary winding. Voltage applied to the winding is E1. Then E1. Then phi is the flux is produced in the winding. Then under no load condition, the small current passing through that winding, that meet the loss of the transformer. That current is I0. Then the power factor angle is phi 0. Then in the case of, we know that the primary I2 dash means I2 I2 is the converted into primary side is called I2 dash. Then total current or input current passing through the transformer is a vector sum of secondary current and no load current. That is magnetizing current, that is vector sum. I2 dash and I0 is vector sum, that is called I1, that is the input current or primary current of the transformer. Then here the power factor is 0, power factor is unity, that is phi angle 0. But in the case of here, for an inductive load, I2 and E2 has a phase difference, that is phi 2. Then I2 dash is this one, I0 is the magnetizing current, vector sum of I2 dash and I0 is the I1. That is for the inductive load. But in the case of capacity load, the leading power factor is provided. Then phi 2 is I2 here, then same as I2 dash. I2 is reflected into the primary I2 dash, I0 is a magnetizing current, then vector sum of I2 dash and I0 is a I1. Then next you go to the regulation of the transformer. Regulation means when the transformer is transformed a voltage from one voltage to another under no load condition, it has a voltage transfer a voltage. Then in that particular condition, transformer is loaded, the voltage is output voltage is reduced. That reduction is the voltage regulation of transformer. Then VNL minus VR. VR is the loaded voltage. Then VNL minus VR divided by VR into 100. That is a percentage regulation. Then its value per unit value 0 to 1. Then for testing of transformer, that is for giving the transformer to a consumer, the manufacturers provide the important information about the transformer, what about its loss, efficiency and other things. So for predetermine, that is for predetermine the efficiency, losses and other things, we use the testing of transformer. First is open circuit test and short circuit test. That is from these test result, we can predetermine the all performance values of the transformer. Then for testing open circuit test, it is used for to find the core loss of the transformer. Then circuit is here. Then the rated voltage is secondary is open circuited and rated voltage is applied to the primary. So for we get a power wattmeter reading, that is maintained the core loss of the transformer. Then short circuit, in that case the secondary is shorted and then connected through an auto transformer. The auto transformer is adjusted to a rated current passing through the transformer by primary. Then and from that case we get a voltage and power, that is called a copper loss. Then from the copper loss and core loss, find out from the short circuit and open circuit test, we can determine the predetermine the efficiency at a different load condition. Means the core loss is always constant throughout the loading condition, throughout the no load and full load condition, and but copper loss is varied. So from that we can determine the efficiency and other performance of the transformer using this test. Then so we already said that the transformer losses find out using the open circuit and short circuit tester. Then transformer losses are classified into copper loss, iron loss, copper loss, iron loss or core loss, stray losses, dielectric losses and other losses. Mainly we can calculate it, copper loss and core loss. Other things are we assume the stray loss and dielectric losses. Then core loss is also again divided into eddy current losses and hysteresis losses. Then dielectric losses, magnetostriction losses and mechanical losses, other losses is also called mechanical losses. Then but in the case of electrical appliances, mainly the losses produced is the copper loss and iron losses in the case of transformer. So we already discussed the static piece of machines, that is transformer. Then transformer is used to convert transform type of electrical energy, one electrical energy to other circuit without changing the frequency and power. Then next is we go to the rotating machines. Rotating machines, first of all, we already see that the AC machines and DC machine, DC voltage is supplied to the motor, or DC voltage is generated from the machine. It is called a DC generator or DC motor. Then DC machines are divided into separately, that is machines either generator or motor, separately excited or self-excited, means according to Faraday's law, the motor is working whenever excitation is needed. Then separate supply is used for excitation, is used separately, is called separately excited. When the voltage generated, that is statoril field കൊടുക്കുന്ന അതേ വോൾട്ടേജ് ആർമേച്ചറിലും വരികയാണ്, that is called self-excited. Self-excited is again divided into series, shunt and compound. Then compound is again divided into cumulative compound, long shunt compound and short shunt, then differential compound and long shunt, differential and short shunt. Self-excited means a volt. In the case of DC generator, a voltage generated voltage generated voltage itself is used for the excitation, is called self-excited. Then when the field coil is connected in series with armature, it is called series. Then field coil is connected in parallel with armature, is called shunt. Then two field coils are there, one is in series and other is in parallel with armature, it is called compound. Then cumulative compound and differential compound, that is compound winding, that is parallel or series parallel winding is in aided voltage condition, and it is called cumulative. Then differential voltage differential compound. Then long shunt and short shunt, that is compound in parallel to connect in ഒരു പാർട്ട് across parallel ആയിട്ടാണെങ്കിൽ that is called short shunt, full parallel ആയിട്ടാണ് long shunt. This is a DC generator. Then it has two parts, field and armature. This one is the armature. Then middle point is armature. Field winding, that is the pole shoe. Pole consists of 4 pole shoes. Then each pole shoes are field winding is connected in series. Then field winding is started from here. Then that is coming to this one. Then this one. Then this one. Then terminal box like outer winding എടുക്കുകയാണ്. ആർമേച്ചറിൽ നമ്മൾ വൈൻഡിങ് കൊടുത്തിട്ട് അത് എടുക്കുക. അതാണ് ഫീൽഡ് ആൻഡ് ആർമേച്ചർ. ഇതൊരു DC ജനറേറ്റർ ആണ്. ദെൻ ഫീൽഡ് എക്സൈറ്റ് ചെയ്യുക. ഫീൽഡ് എക്സൈറ്റ് ചെയ്യാന്ന് വെച്ചാൽ ഇഫ് ഇറ്റ് ഈസ് സെപ്പറേറ്റ്ലി എക്സൈറ്റ് ആണെങ്കിൽ സെപ്പറേറ്റ് വോൾട്ടേജ് ഇസ് യൂസ്ഡ് ആസ് ആൻ എക്സൈറ്റേഷൻ വോൾട്ടേജ്. ദെൻ ഫീൽഡ് എക്സൈറ്റ് ചെയ്യുമ്പോൾ മാഗ്നറ്റിക് ഫീൽഡ് ഇസ് പ്രൊഡ്യൂസ്ഡ് ഇൻ ദി എയർ ഗ്യാപ്പ്. ദെൻ ആർമേച്ചറിലും ഉണ്ട്. ആർമേച്ചർ റൊട്ടേറ്റ് ചെയ്യുമ്പോൾ magnetic field cut by the armature and EMF is generated here. Then EMF is generated. That is a DC generator. Then the working principle of DC generator using this condition, that is North Pole and South Pole. These are then we can assume this one is a North Pole and this one is a South Pole. And North Pole and South Pole, in between that magnetic field, a conductor is rotated in 360 degree. Then we get, first of all, it is rotated in 0 to 180 degree. Then we get a positive voltage. Other 180 to 360 degree, it will get a negative voltage. So ideally it generate a AC voltage, but in the case of commutator segments, it is converted into DC. Then different parts of DC machines are core, commutator segments, windings and brushes. Core is high permeability silicon steel, magnetic content ഉള്ളതാണ്. Then commutator segments hard copper. Then body, mild steel cast or cast iron, windings, copper, brushes, carbon brushes are used. These are the field winding and armature core and armature conductors, and brushes are here. This is the commutator segments. Then term in between, in this the brushes we can connect. Then in DC machines, we already told that two actions are there: generator action and motor action. And EMF is induced in a conductor. Then if it moves through a magnet, that is conductor moves in a magnetic field, an EMF induced in it, that is called a DC generator. A force is induced in a conductor, that is current going through it and placed in, that is a current carrying conductor is placed in a magnetic field. It is the force, rotating force is produced, that is a motor action. Then this is a direction of flux. That is in 0 to 180 degree, a positive half cycle is provided. Then 180 to 360 degree, a negative half cycle is produced. Then with the help of commutator segments, negative half cycle is again converted into positive half cycles. Thus, in that cases, we get a positive voltage or DC voltage from the DC generator. Then different losses in a DC machines, that is mechanical input, that is it is a generator. Mechanical input power is applied to the DC generator. Then from the mechanical losses, it will produce a mechanical losses. After the mechanical losses, it is passing through the wide field. Then field core loss and armature core loss ഉണ്ടാവും, field core loss ഉണ്ടാവും. Then copper loss, that is fieldilum armatureilum winding ഉണ്ട്. Copper loss means it is nothing but I square R loss. I square R loss എന്ന് വെച്ചാൽ ഫീൽഡിലും copper loss ഉണ്ട്, armature copper loss ഉണ്ട്. Then in addition to this, windage losses and other stray losses. But this type of 4 main type of losses are produced in mechanical input. After these losses, we get a power, that is in the form of electrical output power. Then that is called generator. So the difference in between electrical output power to the mechanical input power is the losses, total losses. Among the total losses, it is consists of mechanical losses, core loss, copper loss and stray losses. Core loss means the loss produced in the field core and armature core. Then loss produced in the field winding and armature winding. Loss produced in the field winding and armature winding is the copper losses. Then it is already told that is 0 to 180 degree positive. Then we already classification, that is separately excited, it has an armature and a field. Then field winding, for field winding and extra separate supply is used, that is called a separately excited DC motor and DC generator. Then there is a shunt machines, a shunt, that is armature and field are in parallel, it is called shunt. Series armature winding and field winding are in series, it is called a series wound generator. Then armature winding and the field winding are parallel, it is called shunt. Then cumulative compound, that is plus minus, then minus is connected to the armature plus it, then field in the shunt field, that is it is compound, it consists of series winding and a parallel shunt field. Then that positive and that positive connected to the negative side of series field, it is called a cumulative. But in the case of here, it is this negative connected to the armature plus is called a differential compound. Then testing of DC machines. Then in the case of transformer, we told that the efficiency and other performance of the transformer is predetermined by testing the transformer using basic test, open circuit test and short circuit test. Here we can find out in the case of, that is, it is a rotating machine, DC machine. We already told that the losses are copper losses, iron losses or core losses, stray losses and mechanical losses. These losses we can find out the two methods, direct method and indirect method. Direct method എന്ന് വെച്ചാൽ efficiency calculating using load test. Indirect method, Simpson's test and Hopkinson test. Simpson's test is a no machine is working is no load. Then the power used by the machine can be measured with the help of wattmeter, that is called core. Then it is a no load losses. Then core loss and copper loss we can find out. Then core loss is always constant. Copper loss is the varied with the load condition. That is, I is varying in linearly, but I square R is a copper losses. That is non-linear case lana adu vary cheyunnathu. So these are the two methods we can find out we can predetermine the efficiency and other performance of DC machines. Simpson's test and Hopkinson test. Then in the DC motors, we already seen that the generator and the power loss stages paranju. Then DC motors motor input VI watt electrical ആണ് ഇൻപുട്ട്. ഇലക്ട്രിക്കൽ ഇൻപുട്ട് നേരത്തെ നമ്മൾ പറഞ്ഞത് മെക്കാനിക്കൽ ഇൻപുട്ട് കഴിഞ്ഞ് ആദ്യം മെക്കാനിക്കൽ ലോസസ്, പിന്നെ ഇലക്ട്രിക്കൽ ലോസസ് ആൻഡ് ഫൈനലി സ്ട്രേ ലോസസ്. Electrical losses, core loss and copper losses. Here input is electrical, so VI what is, that is input loss is the copper loss and core loss is here produced. Then power, driving power in armature EB into IA, that is a mechanical power, and iron and friction losses, motor output in mechanical. This is a motor in the power stages, generator in the power stage, electrical, mechanical input, mechanical losses, core losses, copper losses, stray losses. Here first of all copper losses, then core loss, then mechanical generated input, that is CB into IA, back EMF into IA, then iron and friction losses, motor output is in watt. Then in the case of motor and generator, we can find out the efficiency equation. That is mechanical efficiency in electrical power developed by the armature. Mechanical power developed by the armature എന്ന് വെച്ചാൽ മെഷീൻ മറ്റേ ഇലക്ട്രിക്കൽ ഇൻപുട്ട് പോയി കോപ്പർ ലോസും കഴിഞ്ഞിട്ട് ബാക്കിയുള്ള പാർട്ടാണ് ഈ ബാക്ക് EMF ഇൻറ്റു IA വരുന്നത്. അതാണ് പവർ ഡെവലപ്ഡ് ബൈ ദി ആർമേച്ചർ ഇൻറ്റു IA. EG into IA, total mechanical input. Then EG into IA divided by total mechanical input. Electrical efficiency means V into IL, that is output by input. So electrical efficiency varumba V output voltage and IL, then EG into IA. Electrical efficiency, this is the electrical efficiency, this one is the mechanical efficiency. V into IL divided by EG into IA. Then commercial or overall efficiency equal to is the product of eta M and eta E, V into IL divided by mechanical energy applied to the generator. These are the important things in DC machines. Then in the case of motor, this is in the case of generator. Then in the case of motor, 1 minus, that is V into IL is the input. Motor in the case, in the case, V into IL is the output. Here V into IL minus total losses, we get the output. That is input minus losses divided by input is the motor efficiency. Input minus losses divided by total power input minus total losses divided by total power. But in the case of generator efficiency, output plus loss, output divided by output plus losses, or output by input. These are the difference in between efficiency in generator and motor in DC machines. Then in nowadays, the DC machines are used for different industrial application. For different application, the speed of the motor is variable. So for getting the variable speed, we can use the different control methods. Mainly two control methods, depends upon the function. Two control methods we can use. Armature control, that is two parts, important parts of the machine is the field and armature. Then armature controlling ആണെങ്കിൽ armature control, then field control, and it is called a field control. Then in the case of machines running, that is the speed obtained of the motor is above the rated speed, we can use the field control method. Then below the rated speed, that means ഒരു മെഷീൻ്റെ സ്പീഡ് 1500 RPM ആണെങ്കിൽ ദാറ്റ് ഈസ് നമുക്കൊരു 1500 താഴെയുള്ള സ്പീഡാണ് വേരി ചെയ്യുന്നതെങ്കിൽ ദാറ്റ് ഈസ് വി ക്യാൻ യൂസ് ആർമേച്ചർ കൺട്രോൾ മെത്തേഡ്. ദെൻ 1500 മുകളിലുള്ള സ്പീഡാണെങ്കിൽ വി ക്യാൻ യൂസ് field control method. That is, the speed of the motor equation is n equal to v minus ia ra divided by k phi. Then in that cases, ia is armature current, ra is armature resistance. So that is not varied by for different particular machine. That is, ra is a winding resistance, another constant. So we can vary only v and phi. Phi is the flux. Flux is varying with the excitation field. Then for variable V, for getting the variable V, we have to vary the voltage applied to the armature. For getting the variable voltage applied to the armature, we can use the power electronic circuits, either DC-DC converter or DC to AC, DC-DC converter. Mainly in the case of DC machine, DC to DC converter are using. Then for that is, either it is used in armature voltage or it is used in field. Then field lana control cheyanengil phi is varying, so we get a voltage speed higher than the rated speed. Then for V, if V is varied, we get a speed less than the rated speed. In that circuit, we can use a DC to DC converter. That is terminal voltage. Terminal voltage and external resistance involve a changing that affects the armature circuit. Then what about the torque of DC motor? Speed of DC motor then equal to that is back EMF. We know that in the case of DC motor, field is excited by using DC supply. Then core is magnetized. Field winding is connected to a supply. Core is magnetized. Then armature is also connected to the supply. So it is current carrying conductor placed in a magnetic field, a rotating force is produced. That back here, that is armature conductor is a current carrying conductor placed in a magnetic field, it produces a torque. So it has a EMF generated due to the speed of the motor, that is back EMF. It is called in the case of motor back EMF. Phi Z and P by 60A. N is the speed of the motor, Z is the number of conductors, and P is the number of poles, and phi is the flux, and A is the number of parallel paths. Means in the DC machine, two type of windings we can use, either lap winding or wave winding. Then for high power rating machines, we can use a lap winding. Means number of parallel path is equal to the number of brushes. If 4 pole ആണ് machine, 4 path ഉണ്ടാവും. Then wave winding it is always 2 parallel path ആണ്. So current passing through the field armature winding is higher. That means power capacity is higher, current is higher. So we can use lap winding. Then these are the DC machines. But DC machines work first of all, field excite field excite magnetic field. Then armature conductor, current carrying conductor. Then it is a magnetic field or current carrying conductor placed in rotating force. Rotating force and motor rotating. Then it has speed control efficiency കണ്ടുപിടിക്കാനായിട്ട് Simburns test ആണ് യൂസ് ചെയ്യുന്നത്. Then Hopkinson test. Efficiency is as depends upon the motor and generator, different type of equation, that is different equations are there. In the case of motor, input minus losses divided by input. In the case of generator, output divided by output plus losses. The basic equation, output by input. Then next is the AC motors. AC motors, then we already know that the voltage applied to the motor is DC. We call it as a DC motor. Then voltage applied to the motor is AC. It is called as a AC motor. Then depends upon the constructions and working. AC motors are two types, synchronous motors and induction motor. Then depends upon the supply, input supply, single phase and three phase is then induction machine, single phase induction motor and three phase induction motor. Then in the case of synchronous motor, that is synchronous machines application, നമ്മുടെ പവർ generating സ്റ്റേഷനിലെല്ലാം synchronous motor ആണ്. Then depends upon the rotor construction. Synchronous machines are divided into two, salient pole and wound rotor construction. Then salient pole mainly use ചെയ്യുന്നത് generator, alternator ആയിട്ടാണ്. Then synchronous machine, it has two windings, stator winding and rotor winding. റോട്ടർ വൈൻഡിങ്ങിൽ നമ്മൾ ഡി സി ആണ് കൊടുക്കുന്നത്. ഡി സി കൊടുത്തിട്ട് എക്സൈറ്റ് ചെയ്ത് ഇത് ചെയ്യുന്നതാണ് ഡി സി മെഷീനിൽ, synchronous മെഷീനിൽ. ഇപ്പോൾ റോട്ടർ, wound rotor machine and salient pole machine, two type of there. The stator is a ring shaped laminated iron core with a slot. Then three phase windings are placed in the slot. That is in the case of AC machines, synchronous machines and induction machines. Then distributed windings are used for construction of stator and rotor. That means stator slots are provided in the stator core, and type of wind, that is distributed type of windings are used in, windings are provided in the slots in the core. Then റോട്ടറിലാണെങ്കിൽ ഡി സി ആണ്, ഡി സി സപ്ലൈ ആണ്. Then winding is slots are provided. Then the single windings are provided in the rotor slots, and supply is given, DC supply is given to the rotor. Then excitation is provided. Then salient pole മെഷീനിൽ നേരത്തെ നമ്മൾ പറഞ്ഞ വൗണ്ട് റോട്ടറിൽ സാധാരണ സ്റ്റേറ്ററിൽ പോലെ തന്നെയാണ്. ഹിയർ ഇസ് എ പ്രൊജക്റ്റഡ് പോൾസ് ആർ പ്രൊവൈഡഡ് ഇൻ ദി rotor, projected poles or pole shoes are provided. So due to that, the diameter of the machine is, diameter of the salient pole machine is higher than that of the wound rotor. അപ്പം നമുക്ക് ഒരു മെഷീൻ കാണുമ്പോഴേ തന്നെ salient pole ആണോ wound rotor ആണോ കണ്ടുപിടിക്കാം. That is, in wound rotor length will be higher than the diameter, but in the case of salient pole diameter is higher. Then stator and rotor, two important parts of the synchronous machines are stator and rotor. Then a distributed winding is provided in the stator. Each, that in three phase, mainly three phase ആണ് യൂസ് ചെയ്യുന്നത്. Then each phase are distributed over the several slots. ഇപ്പോൾ ഒരു 36 സ്ലോട്ട് ഉണ്ടെങ്കിൽ 12 സ്ലോട്ട് വെച്ച് 36 സ്ലോട്ട് 4 പോൾ ആണെങ്കിൽ 4 ഗ്രൂപ്പ് ഓഫ് 3 phase ഉണ്ടാവും. Three phase winding are wounded by, that is mainly we know that two type of three phase connections are there, star and delta. Mainly star is used for the synchronous machines. Then rotor, that is, it is also a distributed winding. It is excited at DC current. Then as per the rotor construction, cylindrical rotor or salient pole rotor, or wound rotor or salient pole rotor. Then in the generator, that is mainly silent pole rotor machines are used as a hydroelectric power plants. That is where it is speed is very low, is always less than 500. Then if the speed is high, turbine speed is high, we can use a cylindrical rotor. Then it is a doubly excited machine, synchronous machines. Then when the synchronous machines is starting, B is the maximum to minimum, then voltage is increased from here. Then we get a AC voltage generated from the rotation of this rotor. Then flux linkage with the stator coil, lambda A equal to N into phi F cos omega t. Cos omega t is the angle of, then N is the number of turns, which phi F is the flux per pole. Then per pole induced EMF in A phase is d by dt of lambda A. Lambda A is the flux linkage in the case of that particular winding. Then from the equation, we can determine the value of E. RMS instantaneous value is 4.44 F into N into phi F. Then F is the frequency, N is the speed, phi F is the flux. Then E and phi are 90-degree phase difference. Then B is this one, then 90-degree lag by V. Then here flux density is maximum, flux is maximum, but rate of change of flux is minimum. Then main important things of synchronous machine, it is rotated in synchronous speed. Synchronous speed equation equal to 120 F by P. 120, then 120 means half into 60. അങ്ങനെയാണ് 120 വരുന്നത്. N equal to 120 F by P. F is the frequency and P is the number of pole. N is equal to 120 F by P synchronous speed. This is the main equation of synchronous machines. Then this is a principle of operation of synchronous machine. From an external source, the field winding is supplied with a DC current. അങ്ങനെ excite ചെയ്തു. ഈ winding excite ചെയ്തു. Then field winding is mechanically turned. അതിനോടൊപ്പം തന്നെ നമ്മൾ മെക്കാനിക്കലി അതിനെ റൊട്ടേറ്റ് ചെയ്യുന്നുണ്ട്. Then rotate ചെയ്യുമ്പോൾ synchronous speed rotate ചെയ്യും. Rotating magnetic field is produced by the field current induced by voltage in outer frame or stator. The frequency of that voltage is a synchronism with the rotor. That is, when the prime mover is here, then prime mover is connected to that rotor. Then the primer excited by the DC source, then it is magnetic field produced and it is also rotated. So that rotating conductor is cut by the magnetic flux and EMF is induced in the stator. The frequency of that induced EMF is same as the speed, that is synchronous speed. Then next one is the induction motors. That is, in industry, main motors, that synchronous motors is mainly use the power factor improvement and generation purpose and other thing, alternate right. And then main equipments, main machines used in industry are the induction machines. Then it is induction machine, due to induction principle it is working. Classification induction machine, that is, it has two parts, mainly two parts, stator and rotor. As per the rotor construction, it is divided into two, squirrel cage and wound type. Then phase applied to the input voltage applied to the motor depends single phase induction motor and a three phase induction motor. Induction generator is also available, that is in a wind power millilella induction generator ആണ് use ചെയ്യുന്നത്. Then these are the main parts of the induction machines. Then this is a stator winding. Then this one is rotor. Then this is a terminal box. Then rotor depends, so that is, we know that the rotor two type, wound rotor and or slip ring or squirrel cage. Then squirrel cage rotor bars are shorted with the help of end ring. That is, it is just like a squirrel cage. So it is called a squirrel cage induction motor. Then induction motor, AC electric motor, in which electric current in the rotor needed to produce a torque is obtained by electromagnetic induction. So it is called a induction motor. Then three-phase induction motors are most common and frequently encountered in the machine in industry. That is, it is mainly used in almost all industries because it's simple design, rugged construction, price less, maintenance easy, then power rating from low power to high power rating ഉണ്ട്. Then 0.5 fractional horsepower വരെ ഉണ്ട്. നമ്മുടെ പമ്പിനെല്ലാം ഇൻഡക്ഷൻ മോട്ടറാണ് യൂസ് ചെയ്യുന്നത്. then its speed is, that is കുറച്ച് ഡിക്രിമെൻ്റ് ഉണ്ടെങ്കിലും ഇറ്റ് ഇസ് മെയിൻലി ഒരു വേരിയബിൾ ഒത്തിരി വേരി ചെയ്യുന്നില്ല, ഒരു മീഡിയം കോൺസ്റ്റൻറ്റ് സ്പീഡിലാണ് വർക്ക് ചെയ്യുന്നത്. Then for getting the variable speed of induction motor, we can in the same as the DC motor, we want to applied voltage one variable, vary the applied voltage. For getting the variable applied voltage, we can use the power electronic circuits. Then construction, that is stator. Then stator has a three-phase stator core and stator slots. Stator winding is provided in the stator slots, and distributed windings are used here. Then rotor, two type of rotors are there, slip ring rotor and a squirrel cage rotor. Then these are the one photo of squirrel cage induction squirrel cage rotor. Then and the main function complete view another squirrel cage rotor. Then these rotor bars are shorted through the end ring. Then this without a core, this has a rotor slots and rotor core. Rotor slots and rotor bar are provided in each slots. Then this one is a slip ring induction motor rotor. Here same as the stator, the winding is provided in the rotor slots, and windings are connected either lap or wave winding. It's same as DC machines, and all the windings are shorted together. Then rotating magnetic field is produced, that is stator has a distributed winding, a three-phase supply is connected to the stator. Then due to the 120-degree phase shifter, we get a rotating magnetic field is produced in the stator core and air gap. Then that rotating magnetic field speed is at synchronous speed. Then it is equation is 120 F by P. F is the frequency of the supply, P is the number of poles. Then three windings are 120 degree each. Then the magnetic field shape is this one. Three-phase sine wave is provided here. Then for getting the magnetic field, that is net total magnetic flux is the sum of the magnetic field produced in A phase, B phase and C phase. Then we know that the sine wave, so BA of t equal to Bn sin omega t angle 0. Here it is 120, there it is 240 degree. That is each windings are connected in 120 degree phase shift. Then for expanding these things, we get the total flux. Then that total flux is mainly depends upon the sin omega t and cos omega t. So it is depends upon the angle, it is a rotating magnetic field. Then working principle, rotating magnetic field cut by the rotor winding and produces induced voltage. That is when a rotating magnetic field rotating magnetic field in a induce voltage induce such a rotor short circuited. Rotor short circuited, that is in the case of squirrel cage and slip ring, the rotor is shorted is above induced EMF on the current carrying conductor on ours. The current is flowing through that conductor, then that current carrying conductor placed in a magnetic field, it will produce a torque. Then torque equal to Kb into Bs. Then speed of induction motor means it is not like that synchronous machine. Synchronous machine, the speed is same as a synchronous speed. But in the here, rotating magnetic field speed is synchronous speed. Then same speed rotate that relative speed is 0. So that means the rotor is stationary. So cherry speed difference rotate that slip, that is called slip. That slip is only working on the induction motor. That is in stationary rotating magnetic field ns equal to 120 F by P. Then rotor speed S into ns. Then slip speed equal to synchronous speed minus actual speed. Then in the case of induction motor, it is also called a rotating transformer. Means In the case of transformer, there is no electrical connection between the primary and secondary. Here also, there is no electrical connection between the stator and the rotor. So we can draw the equivalent circuit. In this is a stator equivalent circuit, that one is a rotor equivalent circuit. Then after that we can convert that rotor equivalent circuit into stator equivalent circuit using the transformation ratio ER and ES. This one is a stator part. Then stator has a winding. Winding, that means coil. Coil has a resistance and inductance. Then it is a magnetizing part. Then that magnetizing current passing through the magnetizing resistance and reactance. Then secondary part, secondary resistance is depends upon the slip part. That is slip 0 ആയിരിക്കും, so the motor is not rotating. നേരത്തെ പറഞ്ഞു. Then losses in induction motor, we told that for predetermine the efficiency and other performance of DC machines and predetermine the efficiency and other performance of the transformer, we can use the different testers. Here also we can use different tests in induction motor to find out the losses and predetermine efficiency and other performance. Then for that mainly we can see that we want to see that what are the different losses in induction motor. And we same as the DC and core and windings are there. Then loss produced in core is called core loss or iron losses. Then due to the loss produced in the current passing through the winding, that is I square R loss, it is called copper loss. So mainly two type of losses are produced in, that is other losses are there, stray losses and friction losses and constant loss. Then copper losses and core loss. Copper loss is produced in the stator and copper, that is in slip ring induction motor and squirrel cage induction motor. Copper loss is produced in stator and rotor. Mechanical power loss is also produced in the induction motor due to the friction and windage. Then this is a power flow in induction motor. Input is AC. √3 VL IL cos phi is the input power applied to the induction motor. Then it is applied to the stator. First of all, the current passing through the stator winding. So stator core and stator winding. So stator copper loss undagum, core loss undagum. Then rotor copper loss. Then after that air gap. That air gap power is there. Then after air gap, the rotor copper loss and friction and windage stray losses. So that we get the output. Input P in √3 VL IL cos phi. Output, it is a motor. Motor ambo P out equal to omega into T or 2 pi n T by 60. Then advantages, that is we told the two type of induction motors, squirrel cage and a slip ring. Squirrel cage, then advantages of squirrel cage and slip ring induction motor is cheaper ആയിരിക്കും. എന്നുവെച്ചാൽ ലെസ് മെയിൻ്റനൻസ് ആണ്, കൺസ്ട്രക്ഷൻ ഈസിയാണ്, മെയിൻ്റനൻസ് ഈസിയാണ്. ദെൻ സ്പീഡ് ഓഫ് ദി മോട്ടർ, ദറ്റ് ഈസ് റോട്ടർ ആയതുകൊണ്ട് സ്പീഡ് ഓഫ് ദി auto transformer starting when, that is one important thing is when the induction motor is starting, the current, that is first of all the back EMF is 0, the full voltage suddenly the full voltage applied to the stator winding, the current produced is very high. That means mainly 1 ohm is the stator resistance. So 415 volt we can apply, then 415 by 1, 415 amperes. So this will be very high. So the starters are used to starting the induction motor. Mainly auto transformer is used, star delta starter and different other starters are we can use. DOL starter, direct online starter. Up to 5 HP motors we can use direct online starter. Thank you.
Thank you all for being a part of today's session. A special thanks to Dr. Mini VP for sharing her valuable knowledge and experience with us. We hope the discussion have deepens your understanding of electrical machines. So with that, we conclude today's webinar. Wishing you all continued success in your academic and professional journey. Thank you.